then they don't get any heat for the rest of the day. So it gets really hot in here, but then by second period, it's super cold. But yeah, if you're hot, I'm sorry. You'll be probably extra hot by the rating. But I like it. I don't mind it. Hey Leo, how you feel? Good. Oh yeah. All right, let's learn ratio test. This is your last one, I believe, last test. As far as I remember, that's true. Unless I'm forgetting something later in 10, 6, or 7, or 8. But watch this. Remember how I said I want to make you a little sheet that has all the tests and everything you need to know? I remember that I've actually made that in the past. So I will print you this maybe when we're done, like when you guys come back from spring break. But this has like every test and everything you need to know, and when it's convergent, when it's not convergent, what to look for, etc. So I'll give this to you soon when you come back from break, probably, so that you know at least all the tests. So that's coming. Be patient on that. But today, like I said, you just have to learn one more test. And this makes you think that you have to learn 2 tests, ratio and root test. But I think you have enough to worry about on the. Oh, hey, Toby. Hello. Do you want to test?
Yes, please.
Oh, wait, you're retaking, right? Yeah. Not taking for the first time. And I wish you luck, all the luck in the world. Thank you. All right. I was saying you have enough tests to worry about that I don't want to teach you the root test because it only applies in very, very specific situations, and it's not tested on the AP test. So I'm going to skip that guy. If you're interested, it's not hard at all, but it's just an extra thing to keep track of that I don't think is necessary. So ratio test, though, I will teach you. Let me make this small. Ratio test says this. Ratio test says essentially that if you take 2 consecutive terms and you take their limit to infinity, then if that ratio is less than 1, then the series will converge, and if you take their limit and that's greater than 1, then it diverges. And this is very, very rare, but if you ever get that the limit is equal to 1, then you have to use a different test. But this rarely happens. Cool. So again, well, maybe let's just get into an example and you'll see what I'm talking about. So ratio test says take 2 consecutive terms, the next one over the current one, and take the limit to infinity of the ratio, and then that will tell you whether it converges or diverges. Let me write it very formally at first, although I've got some stuff to say after this step. All right, take the limit to infinity of this sum right there, but instead of an n, put an n plus 1. That's like taking the next term. So 2 to the not n, but n plus 1 over n factorial, or sorry, n plus 1 all factorial, like that. And then that's over the, oh my goodness, okay, sorry, one sec. All these tables. That's over the original sum, like the thing that you see right here, that'll go over that. All borders, so I can see. Now I want to delete this. I want to delete this. I want to give myself room here. Room here. Okay. Okay. This over. Okay. That over the sum that I started with, n factorial, like that. Cool. And then technically, I should check the absolute value of these, because this also works on alternating series. Although in this case, everything's positive, so I don't need the absolute value. But just to match the little description in the box, I'll put the absolute values. Also just good to get used to for later sections anyway. Okay. Cool. And then if we're going to take this limit, it's easier than it looks, and then we'll determine if this converges or diverges. This ratio test, by the way, I should say, is like the one that you use the most. It applies the most often, and it's useful for other things that we'll learn later in the unit too. So this is like an important one. But okay, let me do two things. Let me get rid of the absolute values because, like I said, these are all positive anyway. So in the next step, I'll just ignore them. And then second thing is if you see a fraction over a fraction, what's your heart tell you? Okay, yeah, that's what I'll do. So in fact, you might even see me in the future skip this step and just jump straight to the keep change flip version. So that in this case, we have 2 to the n plus 1. This guy stays the same. Times this flipped over, so n factorial over 2 to the n. Okay. And now let's do the simplifying that we know for sure. Do you guys know how 2 to the n plus 1 over 2 to the n, how that can mix and combine and simplify? Yeah, that might be too abstract. But what if it said 2 to the 3 over 2 to the 2? Yeah. Yeah, exactly. That's what's going to happen is you can subtract these two. 3 minus 2 is 1. Same thing here. N plus 1 minus n is, of course, 1. Because this is 1 more than n. So n minus n is 1. So subtract those two exponents, you just get 2 to the first on the top. And then this one I would be very impressed if you knew. But do you guys know what n factorial over n plus 1 factorial would be? Yeah, that one is not so. It's kind of easy if you think about some real actual numbers. So here for the people in the video, let me talk about what is it? N plus 1 on bottom. Yeah. Okay. So let me do like 7 factorial over 6 factorial. If you just write that all out, that's 6 times 5 times 4 times 3 times 2 times 1, and then 7 times that same thing. So now ideas, well, what's going to happen to this one with the concrete numbers? Yeah, exactly. All of these will piece out all of these, and you just get 1/7. Yeah, no.
1 over n plus 1.
That one. Yeah. All of the factors before, what I'm saying is basically n factorial, or sorry, n plus 1 factorial is just n factorial times one more term. So all of the other terms will cancel except that biggest one. So here you just get 2 over n plus 1 like that. So this crazy looking thing actually turned into this very simple limit to take. Again, if you're not confused, or sorry, if you're not convinced, like plug in more specific numbers, like plug in 7 factorial and 8 factorial, and 8 factorial and 9 factorial. You'll see you'll always get left with the 1 over the biggest number. All right, cool. And now we're here, and you take this limit to infinity, and what happens to it? Yeah, that's 0 because the top is staying put, the bottom is getting huge. This limit is 0, and I know you've had a million tests to keep track of. Sometimes 0 means one thing, sometimes 0 means a different thing. In this case, anything smaller than 1 is good news, meaning that the sum converges. So I'm going to say final answer n equals 1 to infinity. This converges by the ratio test. Shoot. Cool. Okay, let me do the next one, and then again, I think you got so many tests to keep track of in your head that it's good to know kind of why each test works, so that way you don't have to, like if you forget on May 11th, you can like derive each test by yourself. But first is first with this next example. Again, we're taking the ratio test, so that would be the limit as n goes to infinity of next term over current term. So see if you can set that up if you're not using a pen. This one's a little bit tricky, I guess, a little bit. Let's set up the initial ratio at least. Okay, check that you set up the ratio like this, or even better if you said n plus 1 plus 1 more is just n plus 2. Let me set that up so I don't have to waste a whole step on that. N plus 2 like that. This looks like you guys aren't editing, so I'm guessing you guys did good on that. Then again, you want to keep change flip. Do I have space over there? No. I'm going to do it down here. Limit is n goes to infinity of n plus 1. Dang it. Okay. Okay. What's up, Bree?
It's the absolute value.
Oh, you're right, you're right. That's just what the ratio test says. It basically, it matters more for alternating series, the absolute values. That's why I forgot it for these two, or like I didn't even think to include them, because plugging in positive numbers into this positive expression is always positive anyway, so taking the absolute value does nothing. But it's a good idea to start getting used to that, because later it makes a big difference. Okay, let me change flip this. What's up, Sam?
Is there any benefit to like writing out the fraction over fraction first, or can you just like skip it?
Yeah, you can skip that. Like that might be better for your time. Like skipping this step is what Sam is talking about. Yeah, that would be totally reasonable. All right, nice. And then again, a lot of things will cancel for the ratio test. So let me see where I can. Let me just make this tiny. This is so huge, taking up my entire space. I'm just gonna make that tiny and put it here, and then. Now I have more space to write on. All right, so cancel everything you can, but this one is a little bit deceptive because, let me just go left to right. This n plus 1 squared over n squared, obviously these two guys would have to match up for something to cancel, and it really feels in your heart like maybe that something should cancel here, but you can't really do that much. These aren't exactly the same term. This is n plus 1, this is n squared. So I don't see any way to cancel those right now. So those guys got to stay. Question?
Can you like factor it out and then cancel n squared?
Not really, because then you'll get like n squared plus 2n plus 1 over n squared. Like those pluses will prevent you from canceling that out. But that's going to become relevant in a second, so keep that in your brain about like expanding that whole thing out. All right, but for now, those don't cancel. They stay as they are. Then, okay, I dealt with this. The 3n plus 2 and the 3 to the n plus 1, what's that going to be, just to make sure? Okay.
Or not 3.
Now I'm confused. No, yeah, the bigger one's on top. So, yes, 3 on top. Okay, 3 on top. And then 2 to the n over 2 to the n plus 1, you tell me again. Yeah, nice. And the bigger one was on the bottom, so 2 down here. Boom. Okay. And then now you're taking the limit to infinity, and as it's, well, do you guys see the limit already or no? Yeah, okay, it's not super obvious. What were you going to say with 1? No.
3/2.
Yeah, but if you don't see it right away, then do what James said. Like, you might have to expand this whole thing. I'll do it just to like show you what I'm talking about. But it would be reasonable for you to do that in your brain and be like, if I did expand this, it'd be n squared plus blah 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 over n squared times 2. So the ratio would be 3/2. Like the limit would be the ratio of the coefficients, which is 3/2. But anyway, I'll show you what I'm talking about. This is 3 times n squared plus 2n plus 1 over 2n squared. And then if I did distribute, this should be the limit, by the way. If I did distribute that, I'd get 3n squared over 2n squared, and those are the same degree, so the limit is the ratio of the coefficients, so 3/2. Okay, ratio test done, but now don't forget to answer the question, does this converge or diverge? Good job, because 3/2 is 1.5, it's bigger than 1. Therefore, this series diverges. All right, what time is it? 24. Yeah, here's 20 good minutes that you guys can spend doing your homework. If you want, or if you have other stuff to do, I understand that. But it's like a good built-in time to practice because you don't, like you've only done 2 examples of each thing, you know. Like if you've just done the notes. All right, and then remind me at some point to tell you the intuition behind this. But I don't want to spend like 5 minutes on that. I'd rather you guys get practice. So I think I'm all done. You guys work, ask me questions, help each other, answer keys on Schoology, and that's all from me.
Oh,
Oh, what's up?
Hey,
why is there's like